Welcome to another lecture on the gas laws. This one will be on the relationship between gas pressure and the number of molecules or mole. Pressure is the number of collisions of the gas molecules with a container wall per second. The more collisions per second, the higher the pressure. The fewer collisions per second, the lower the pressure. So if you take a look at pressure, it's dependent upon three things: the size of the container or the volume, the speed of the molecules, the temperature, and the number of particles. So we're going to cover the third one here, and the relationship between pressure and moles. So we take our container, we have our 10 gas molecules. It's at 298 Kelvin, 5 liters, and it'll have some pressure x kilopascals. Now assume we double the number of gas molecules. We've kept the temperature the same, we've kept the volume the same, doubled the number of gas molecules. By keeping the temperature and the volume the same, kept the speed and distance the same, but as I said, we've doubled the number of molecules. Therefore, the number of collisions per second should double. Double the number of collisions, the pressure goes up. As a matter of fact, it doubles. We could now say the new pressure is 2x kilopascals. This relationship between pressure and moles is known as Avogadro's law. This is assuming that we are holding the volume and the temperature constant. Numerically, P1 divided by N1 equals P2 over N2. This is a direct relationship. If you increase the moles, you have to increase the pressure. If you decrease the pressure, has to decrease. If you hold volume and temperature constant, if the pressure increases, you know that the number of moles must have increased. And under the same set of conditions, if the pressure decreases, then there must be fewer moles. So let's start putting this into practice. You've got an 8-liter rigid, which means it doesn't change size, container. The temperature is 350 K and has 1.25 moles of nitrogen. Pressure is 454 kilopascals. Then an additional 4.22 moles of nitrogen are injected into the tank. There's no change in temperature, so there should be a new pressure. What would that be? Let's take a look. We're going to use the guess system. What are you given? What's the unknown? What equation? Substitute into the equation, then solve it. So we're given P1, 454 kilopascals. We're given N1, 1.25 moles. We are told that we add 4.22 moles, so we know that now in the container there's 5.47 moles. That's N2. The unknown is P2, that's what we're looking for. We'll be using Avogadro's law. P1 over N1 equals P2 over N2. So now substitute what we know, and you come up with this equation: 454 kilopascals divided by 1.25 moles equals P2 divided by 5.47 moles. Now solve. So we're going to get P2 by itself, so we rearrange, multiplying both sides by 5.47 moles. Once again, notice the moles cancel out, leaving us with kilopascals. Math, you get 1,987 kilopascals. Given that that is our new pressure, does the answer make sense? And we go, yes, it does. Moles increased, as did the pressure. Makes sense. Here is a second one. This one you can try first. We've got a rigid container that contains 0.360 moles of a gas, and it's at room temperature. The pressure is 11.75 atmospheres. When the whipped cream is all consumed, now the pressure is reduced to 1 atmosphere. How many moles of nitrous oxide remain in the can? Stop, figure it out, come back and check your answer. And the correct answer is 0.0306 moles. How did we get this? Well, we were given P1, N1, and P2. The unknown is N2. The equation is Avogadro's law, so we substitute in our various values. We rearrange to isolate N2 in the numerator. We solve this, and we get 0.0306 moles. So here's one last problem. A rigid container has 9.51 times 10 to the 25th molecules of propane. The pressure of this tank is 3,993 torr. Then 3.49 times 10 to the 25th molecules of propane are then removed from the tank. What's the new pressure? Be sure you read the question carefully. We're going to assume that both volume and temperature do not change. So now stop, figure out your answer, come back and see if it was right. And the correct answer is 2,527 torr. How did we get this? We're given P1 and we're sort of given N1. Well, we know that moles times 6.02 times 10 to the 23rd molecules per mole equals the number of molecules. We know that we have 9.52 times 10 to the 25th molecules of propane. Divide both sides by 6.02 times 10 to the 23rd. You get 158 moles. So now we do know N1, it's 158 moles. But what's N2? We start with 9.51 times 10 to the 25th molecules of propane, and we removed 3.49 times 10 to the 25th molecules. So we must be left with 9.51 times 10 to the 25th minus 3.49 times 10 to the 25th, or 6.02 times 10 to the 25th molecules. Plug it into the usual equation, rearrange, and you end up with 100 moles. So now we know N2. The unknown is P2. Avogadro's law comes into play again. Substitute in the values, rearrange so you can solve, and you get 2,527 torr. So, to review, once again, pressure is collisions per second with a container wall. If we hold temperature and volume constant, increasing the moles increases the number of collisions per second, which means increasing moles increase pressure. And if you increase the pressure under these conditions, then you must have increased the moles. Conversely, decreasing the moles decreases the number of collisions per second. That decreases the pressure. But if you notice that the pressure is decreased, holding the temperature and the volume constant, then you know the number of moles must have decreased. This is a direct relationship. Both pressure and moles will change in the same direction. This is known as Avogadro's law. Once again, I will not test you on the names. You need to understand the mathematical relationship of P1 divided by N1 equals P2 divided by N2. And that completes this video. In the next video, we're going to cover one more separate gas law, and then in a following video, we're going to put everything together.